Hello everyone, very good morning to you. Myself Kirtan Sangvi, working as a assistant professor in LJ Institute of Pharmacy. Today we are going to discuss about geometrical isomerism, one of the important type of stereoisomerism. What about its definitions? What about their types? What about nomenclature? Where it is applicable? We will see in this presentation. Fine, let us see. Geometrical isomerism, if I define, it is a type of distereoisomeric relationship. It means what? When we talk about stereoisomers, there are mainly two, enantiomer and distereomer. Enantiomers are mirror images isomer, distereomers are not mirror images isomer. So when we talk about geometrical isomerism, they are not mirror images of each other. So it is a type of distereoisomeric relationship in which rotation is restricted or hindered, or you can say prevented around C double bond C. When you talk about C single bond C, for an example, let's see C single bond C, when there is a continuous rotation of the substituent around the bond. I mean to say that is called as a flexible isomerism, conformational isomerism, which we will discuss in alkane, ethane, butane and so and so. But if we want to prevent rotation around C single bond C, definitely we have to put one additional bond between carbon and carbon. So it means C double bond C, it's all about geometry of alkene, definitely. So it is a type of distereoisomeric relationship in which rotation is restricted or prevented or hindered around carbon-carbon double bond. Fine. So that is called as a geometrical isomers. When I say geometrical isomers, being a distereomers, they have different physical and chemical properties. It means their melting point, boiling point, density, viscosity are absolutely different. And hence, we can easily separate a single geometrical isomer from the mixture by mainly two techniques. You must be knowing, I say, that is fractional distillation and fractional crystallization. Fine, sure. Next, when I say nomenclature, as usual, there are two types of method. One is cis-trans isomerism and another we will study today, that is E and Z type of nomenclature. Fine. Now, if I talk about C double bond C, there are mainly two possibilities. Either substituents which are attached with the double bonded carbon, they are same, or all four substituents are different. So when I talk about same substituents which are attached with the double bonded carbon, cis-trans isomerism is applicable. It means what? If two substituents are on a same side of plane, the isomer is cis, opposite side of plane, isomer is definitely trans. Let us see in example. Fine. Here I have mentioned one example, cis to butene and trans to butene. It means what? Double bonded carbons are having same substituent. Each carbon is having same substituent. It means carbon is attached with CH3 and H. Another carbon is also attached with CH3 and H. And when same substituent are on a same side of plane. Now you will be surprised. Here C double bond C is there. It means what? Carbon is sp2 hybridized carbon. And we all know very well the bond angle of sp2 is 120 and shape of sp2 carbon is definitely planar. Fine. So substituents are on a same side of plane. Isomer is cis. If two methyl groups are on a opposite side of plane, isomer is definitely trans. So cis-trans isomerism is applicable to those alkenes when substituents are attached same. And let us see a second case. Here we have put one more example, dear students, that double bonded carbons are not having same substituents. All four substituents are different. Fine. So what will happen? We have to assign priority at each carbon. And when I talk about priority, CIP rules comes into the picture. Kahn Ingold Prelog system. You must have studied. Fine. RS configuration. The rules, same rules are applicable here. Fine. So let us assign priority at each carbon. Here I have mentioned one more example here. When if I talk about C double bond C carbon, on a left hand side, the carbon is attached with CH3 and H. So we all know very well atomic number of carbon is higher as compared to hydrogen. So CH3, that carbon is having highest priority. If I talk about left hand side carbon, if I talk about right hand side carbon, look at that, there are two different substituents. In fact, right hand side carbon is attached with the carbon. Fine. So what we'll have to do? As per CIP rules, we have to go to the next atom. It means what? In case of right hand side, the first substituent is CH2CH3. It means that carbon is attached with two hydrogen and one carbon. And if I talk about the another substituent, that is CH3CH3H, it means that carbon is attached with two methyl group and one hydrogen. So definitely two carbon and one hydrogen. So CCH will take priority over HHC. Fine. So when I talk about the priority on both the carbons, you see I have mentioned here same substituent, same priority on a same side of plane. I mean to say highest priority. Fine. This carbon highest priority is this carbon highest priority is this. If they are on a same side, the isomer is called as a Z. Z stands for Jusamen. And if I talk about E isomer, that is highest priority on a opposite side of plane, that isomer is called as a antagon. Antagon, E stands for opposite. Both are actually Greek word. Fine. Look at that. Here I have mentioned E isomer as well. Fine. Where highest priority if you see on opposite side of the plane, and hence the isomer is called as a E isomer. So when all four substituents are different, definitely we have to go for the system E and Z. As we have seen in definition, it is a type of distereoisomeric relationship in which rotation is prevented or restricted or hindered around carbon-carbon double bond. But what will happen, dear students? There may be a chances that carbon is attached with nitrogen double bonded. There may be a chances nitrogen is attached with nitrogen double bonded carbon. What will happen? Is it possible in that case? Let us look. Geometrical isomers, as far as C double bond C system is concerned, we have studied. Now it is also applicable to C double bond N as well as N double bond N type of system. Let us see example. Here the first example I have mentioned is hydroxyethanamine. Fine. Here you see carbon is attached with nitrogen double bonded. And if I say nitrogen, lone pair of nitrogen is considered as a fourth substituent. So what will happen? Here when I talk about C double bond N, you see in the first structure, this nitrogen is attached with hydroxyl group. This carbon is attached with CH3 and H. I mean to say all three are absolutely different. So definitely cis trans won't be possible. So what will happen? We have to go for E and Z. And if I talk about E and Z, E means highest priority, opposite side. Let us see here the carbon is attached with CH3 and H. So CH3 will take priority over the H. And if I talk about nitrogen, only one substituent is there, that is OH. So of course CH3 and OH, they are opposite side of plane. The isomer is definitely called as a E isomer. And if you say Z isomer, where CH3 and OH are on a same side of plane. So what my ultimate point is, geometrical isomerism is not restricted up to C double bond C. It may be possible in C double bond N and as well as N double bond N type of system. Look at that. I have mentioned one more example, dear students. Fine. Azobenzene. Okay. You can see trans and cis. Trans, both the phenyl rings are opposite side of plane. If both phenyl are on a same side of plane. Here, both are phenyl ring system, and hence I have mentioned cis and trans. Fine. Cis and trans and E and Z. What gonna be difference? E and Z, you can definitely say cis and trans, but cis and trans will not always said to be E and Z. That is the main point. E and Z is definitely said to be trans and cis, but if I talk about cis and trans, you not always say they are E and Z. This is very important part. One more example that you must have studied in Bachmann rearrangement. Fine. C double bond and type of system. I mean to say oximes are converted into amide, where alkyl group is going to migrate, but which alkyl group? The group which is opposite, I mean to say trans to that hydroxyl group, that is going to migrate. Fine. So let us see. Geometrical isomerism, dear students, is not again restricted up to double bonded system. That we are extending the definitions. Once we said it was possible in C double bond C type of system, then we have revised. It is also applicable to C double bond N type, N double bond N type of system. Now I say it is also possible in cyclic aliphatic system. I mean to say cyclic system. But here I want to put one more word, that is suitably substituted cyclic aliphatic system. Fine. If the substituents are not there, I say cyclopropane, cyclobutane, cyclopentane, cyclohexane. If you do not substitute, cis trans won't be possible. But if two carbons are substituted, then definitely we should apply cis and trans system. Fine. But what is the speciality of this system? E and Z we never applied in case of cyclic system. We always have to say cis and trans. Now, what is a definition of cis and trans in these cases? Let us look. Here, first example I have mentioned is 1,3-dimethyl cyclobutane. Cyclobutane, cyclic aliphatic compound 1 and 3. There are substituents called as a methyl group. If methyl group on a same side, but how can we say same side? If both the substituents are on a upward direction, that is called as a cis. I mean to say same side. And if one substituent is upward, another substituent is downward, definitely we say that isomer is called as a trans isomer. Actually, in cyclic aliphatic compound, I have to say there are two positions. One is axial, another is equatorial position. So axial position, that is perpendicular to the plane, and equatorial position is somehow lie in a different plane. We all know very well bond angle must be 109.5. So substituents must be arranged in that manner. Fine. Let us have one more example. Here cis-1,2 dibromocyclopentane I have mentioned. So cyclic aliphatic system, if you see in the diagram, both the bromines are on an upward direction, the isomer is said to be cis, and if one bromine is upward, another bromine is downward direction, the isomer is definitely called as a trans isomer. Fine. So concluded aspect, if I say geometrical isomerism is possible in three different cases: C double bond C, C double bond N, N double bond N, maybe some other double bonds, but double bonds are there, definitely that is possible. And number three is very important: suitably substituted cyclic aliphatic system. Fine. Okay. So of course you must have enjoyed this video. Fine. These all videos will be uploaded in Pharma Ignite, that is our YouTube channel. So do subscribe and definitely learn at home. Thank you.